Okay, this is activity number 1 in lab number 7 on February 28th, 2023. So it's a typical problem that's coming from an older midterm or final exam. I'm not sure. You're given this geometry. It says that the top edge AB is clamped and this edge CD is pushed in the direction shown by a certain amount. You have to use the most appropriate element, and as soon as you see that, you should realize that this needs to be done with shell elements in this course, okay? And use as many planes of symmetry. Now, in this case, there is only a single plane of symmetry, which is cutting it this way. So the choice is yours whether you want to cut it now or do half of it. That's entirely up to you. By the way, to create this surface, because you're going to be using shell elements, I mean, you can do it based on creating a solid object, extracting surfaces and things like that, or create the surface directly. And that is how I'm going to do that, okay? So let me go ahead and uh, first create this base here. See that? Create this base right there. And then I'm going to take these edges, 3 edges, and extrude it up so you create something like this, and then I'm going to cut it. Okay, so let's go ahead and start with a Catia file, part file. We're still not doing any assemblies. That's why I rather stick to the parts as opposed to assembly. So file, save management, save as, not in this folder, go up, activity lab number 7, activity 1, and there we are. So on a convenient plane, on that plane, I will sketch that rectangle of size 4 by 6. That's really the base, 4 inch by 6 inches. So this is going to be 6 inches. This is going to be 4 inches. Okay, exit, and oh yeah, actually, what I'm going to do in here, I will also draw a circle of that radius. I believe that radius is 1. Now, on purpose, I'm going to do it like this, and then I'm going to use the output feature, and you can do this a zillion different ways. So that's how I'm going to do that. So first of all, dimension this radius of 1. You do it any way you want as long as you solve that problem. I don't care how it's done. Okay, now, first of all, I'm going to fill this thing. The problem is that when I fill this thing, you will not be able to use this later on for cutting purposes. So let me go back to that sketch and use the output feature basically to create a feature that can be used for this kind of thing that we have in mind. Now that kind of thing means eventually splitting it. Okay, so right now we're going to do a fill of that, and I can use the split now, select that face, and use this feature that I extracted to cut it. You can do this thing any way you want. Now, let me hide the sketch, by the way, hide the sketch, and I'm going to hide this guy too. And I'm going to take these 3 edges and extrude it upward. So let's see now, extrude this in the direction Z by 1 inch. Okay, the same thing on this side. We can, I mean, if you see the mirror, you can also mirror it, but I don't see it right off the bat here where the mirror is. It could be that it's there, but that's entirely up to you how you want to do this. So let me see if I can find mirror. Maybe we can use some things that we haven't used before. I don't see mirror. Maybe buried somewhere here. Oh, actually, what is this? Translate. Um, you can probably also translate this thing by 6 inches. Do that kind of a thing. But let me see. Is there mirror? Is this mirror? Symmetry. Okay, so let's see now. Rotate, translate. I still don't know whether that symmetry is going to. Well, let's try this. We haven't used it, so let's try it. So it says element is this, reference is that. Oh, good, excellent. And this one I'm going to extrude up 1 inch, direction Z. Good. Now notice that these things have the same thickness. The thickness is the same for all of them, and it says wall thicknesses are 0.1. So to make my job easier, it's better to join these things, okay? Because then when I put a thickness, it's going to put on all of them. Join this and that, and that. Okay, let's split this thing. Element to cut is that join. Cutting element is this plane, and it doesn't matter which side we pick. Good. So let's make it out of steel here. Metal, steel on that part. Good. And we're pretty much done. So we're going to go to generative structure analysis. I'll do not a fancy mesh, but just a regular 3-noded triangular element, or parabolic one, 6-noded, whichever you feel like. Right there, you can see this. Okay, let me do this and that, and parabolic. Why don't I select the find a mesh around this hole? How about that? I like to do that. So we say okay. To do that, actually, I could have done it here, local. So edge distribution, add this edge, okay. Maybe, I don't know, maybe 20. That's going to be a lot of elements there, okay. And if you want, by the way, you can select these edges too. Why not? That's not needed really, but okay. And if you look at the mesh now, you see there's a fine mesh around that, around these things. Unless I'm asking you to do it on the test, please don't use local mesh refinement. That's unnecessary. Anything that you don't want, you can hide it. Let me see now. Hide. Oh, deactivate this actually. Okay, good. Now, this top edge is clamped. Top edge is clamped. Okay. These are in planes of symmetry. These three edges are in plane of symmetry. So let's user define. Let's uncheck everything. Uncheck everything. So this edge and that edge and that edge, they all lie in the YZ plane of symmetry, so there is no displacement in X perpendicular, and rotations are exactly the opposite. And I want to take this edge and pull it, but in order to pull it, first I have to give it a zero displacement. So this edge, first in the direction Y to be zero, because then I can go change it. Under enforced displacement, you can go and select this restraint that you put in there, and translation going to be 0.001. I think it was 0.001. I forgot. Yeah, I forgot to put the thickness. If I try to run it, it's going to give you an error message saying that field acquisition not found, something like that. Let me just convince you actually. Let me try to run it. It's going to acquisition of field model failed. That's because you didn't specify the thickness of this. So let's go to 2D property on that face. That because they're all joined, it's all going to put it on the same on the entire thing. And I believe the thickness was, you were given to be thickness to be 0.1 inch. Good. Let's save the analysis. File, save management. This analysis, save as in that folder, activity 1. Good. And now let's run it. This time it will run. Yep. Needless to say that it will look like that because this edge is clamped. When you try to pull this thing to the right, it actually also goes up. It goes to the right and goes up. If you look at the deflection, let's change the rendering here to material shading. You can see that Yes, it goes to the right, but it also goes up. And you can look at the von Mises stress if you want. All these numbers are totally useless. And the reason I say that is that we have not done any mesh conversion study. We don't know how reliable these answers are. I mean, you know how the process works and how to generate these numbers, but these numbers may be totally useless. Okay? So that takes care of this activity.